logarithms. So in lesson 4, we were looking at going from exponential form to logarithmic form. So we looked at the form y equals 2 to the power of x and y equals log base 2 of x. So we learned that the point 3 and 8 on the graph of y equals 2 to the power of x represents 8 being equal to 2 to the power of 3. And the point 8 and 3 on the log graph indicates that 3 is equal to log base 2 of 8. So the exponential form equals 2 to the power of 3, and the logarithmic form 3 equals log base 2 of 8 are equivalent. So what we're going to look at is we're going to look at evaluating logarithms without the use of a graph or a table, because sometimes it's not going to be efficient to have a graph and a table. So Kelsey's asked to work on evaluating log base 2 of 8, and her work is shown below. Study the work, and then we're going to describe the steps that she took. Okay? Do I get something to drink? Oh, okay. Okay. So she starts off by letting log base 2 of 8 be equal to v. So her process was to represent log base 2 of 8 with an unknown value v. So log base 2 of 8 is going to equal v. What did she do in the second step?
Put it into exponential.
Okay, so change to exponential form. So now I have 2 to the power of v equals 8. The next step we have 2 to the power of v equals 2 to the power of 3. So what was the step? What did I do from this point to this point?
Used common base.
Used common bases. And then I have v equals 3. So where does this come from?
And it's common base, the exponents will be the same.
So I compare the exponents. And then the 3 dots, have you been introduced to what the 3 dots mean? Therefore, log base 2 of 8 is equal to 3. So if I go back from the top step, all Kelsey's done is replace v with 3. So we're going to use this concept to evaluate some logarithms. So if I look at class example number 1, log base 3 of 81. So I start these off the same way. I'm going to let this equal a value of v. And then rewrite it in exponential form. So when I take this logarithm and I write it now as an exponent, what would I have? Three to the power of what?
80.
Equals.
81.
And then I want to use common bases, so I want to write 81 as a power of 3. 3 to the power of what? 4. So then v would be equal to 4. So then I can write down that log base 3 of 81 would now be equal to 4. So I want you to use a similar process to do the next 3 questions.
I'm special.
No.
So we have log base 4 of 64 equals v. So 4 to the power of v would equal 64. Common bases would be 4 to the power of 3. So then I can write that log base 4 of 64, or sorry, not 6. Log base 4 of 64 is equal to 3. And then log base 7 of 7. I get 7 to the power of v equals 7. So it's already written as common bases. What are the exponents going to be? V equals 1. Because this would be an exponent of 1. So log base 7 of 7 will equal 1. What would log base 5 of 5 equal? So what would log base 8 of 8 equal? 1. So this is an important one to realize because when the base and the argument are the same, the value is always going to be equal to 1. So if I look at the last one, I get log base 12 of 1 equals v, so I get 12 to the power of v equals 1. And when I'm writing common bases, what I want is I want this 12 to have, or this 1 to be written as 12 to the power of something. 0. Because I wrote 0 on the other side.
I didn't actually see that.
So then v is equal to 0. So then log base 12 of 1 would be equal to 0. What about log base 5 of 1?
0.
Log base anything of 1 is going to be equal to 0. So this is another important property to realize. And we repeat them in class example number 2. Only now we're not looking at log base 7 or log base 6 or log base 12. It's log base b. So if I follow the exact same steps, let this be equal to v. I get b to the power of v equals 1. And then if I was to use common bases, there's my b to the power of 0. So then we have that log base b of 1 would then be equal to 0. And I'll give you a moment to go through the same steps for b with log base b of b. So again, if I let this equal b, I have b to the power of v equals b, which is actually an exponent of 1. So b equals 1, so then I can have log base b of b would equal 1. Okay, so we're going to continue on. I'm going to give you some time, or actually, let's look at class example number 3. We're going to look at this as being 2 times log base 8 of 512. Equals v. So then what would I do?
Divide both sides by 2.
Divide both sides by 2. Good. And then what?
To the power of b over 2 is 512.
Okay. Can I write 512 with a base of 8?
8 to the power of 3.
8 to the power of 3. So I have that v over 2 is equal to 3. So what does v equal?
6.
6. So then log base 2 of, 2 times log base 8 of 512 will equal 6. So similar process for b. As an exponent, I would have 2 to the power of v equals 1 over 32. So let's just look at the 32 right now. Don't worry about the 1 over. If I write 32 as a base of 2, it would be 2 to the power of what? 2 to the power of 5. So I have, in a sense, kind of a common base because I have them both as 2's, but they're not really a common base because this is a 1/2. How would I make this 2 to the power? In other words, how would I bring the 2 up?
Make the exponent negative.
Make the exponent negative. So then v would equal -5. So then log base 2 of 1/32 would equal -5. And then with the last one, I have 5 to the power of v equals the square root of 125. If I have to take out that square root and write it as a power, what would I get as a power? So the square root is to the power of what? 1/2. The index is 2. That becomes the denominator of my rational, and the exponent would be 1. So this would be 125 to the power of 1/2. Can I write 125 as a base of 5?
To the power of 3.
And then that's raised to the power of 1/2. So then together, what would I have here if I simplify this 5 to the power of 3 to the power of 1/2? What would I have? To the what? 3/2. So then v would equal 3/2. So then log base 5 of the square root of 125 would be equal to 3/2. Okay, so we have one last set of examples, and then I'll give you some questions, some practice questions to work on. So if I have 5 to the power of log base 5 of 25, what I want to do right here is we're going to concentrate on the log base 5 of 25 and figure out what the value of that is. So we go through the same process that we did before. So if I write this as an exponent, what would I get?
5 to the power of v equals 25.
And what's 25 with a common base?
5 squared.
So then v would equal
2.
2. So then instead of 5 to the power of log base 5 of 25, I now have 5 squared, which is,
25.
okay? So I want you to do the same thing with 2 and 3. So if I concentrate on my log base 7 of 49, and I try to figure out what it equals, I get 7 to the power of v equals 49, which is 7 squared. So then v equals 2. So now I have 7 squared, which equals, and then for the last one, log base 3 of 27 equaling some value. So 3 to that value equals 27, and 27 is 3 cubed. So v equals 3, and I have 3 to the power of 3 equals 27. So based on the observations of these 3 examples, what would be the value of a to the power of log base a of n?
A to the power.
Which one would it be?
Is it n? Based on your observations, what is the value?
Would it equal n? 25, 25, 49, 49, 27, 27. So it says use inverses to explain your answer. So in other words, we're looking for more of a proof. So the inverses is raising a base to a power. So there's my base. Raising a base to the power and taking the log to the same base. Are inverses. So then if I look at the last one, it says determine the value of log base A of a to the power of n. So if I let this be equal to b, like I did before, what I now have is I have a to the power of b will equal a to the power of n, which then means that v would be equal to n. So if I rewrite this statement, I have log base a of a to the power of n becomes equal to n. So the questions that I want you to start with for practice, question number 1, B, D, E, and F. Question number 2, and questions 3, A, and B.
Yeah,
Let's look at log base 50. If we try to use our toolbox that we have for log base 50, where we say log base 5 of 50 equals b, and then we write it as an exponent. So I get 5 to the power of v equals 50. What problem do we encounter? Because what would be my next step at this point?
Have a base of 5.
Have a base of 5. And what happens when I try to find a base of 5? You can't really find one, because what do we know? We know that 5 squared is, and 5 cubed is.
100.
So at best I can tell you that it's somewhere between 2 and 3. But now I have to guess and check. I have to go 5 to the power of 2.2 or 2.1, and really, do we want to spend a lot of time doing that? So we need to find another method. So the problem is I can't find, there's no common base. So in B it says choose the correct alternative. The exact value of log base 5 of 50, is it between 1.5 and 2? Well, we've already said it has to be somewhere between 2 and 3. So between 2 and 2.5, or 2.5 and 3. So what I want to determine is what is 5 to the power of 2.5? So is it between 2 and 2.5, or 2.5 and 3? 2 and 2.5. So this is, from here, then we could try to streamline it. We could try to go 5 to the power of 2.4, and then try to get it between 2.4 and 2.5, and keep going down. But that's a time-consuming method. So what we want to do is we want to find a way that possibly I could use a calculator to help me do this. So this is where we get into common logarithms and natural logarithms. So have you used logs in science, in chemistry? So when you use logs in chemistry, we use common logs. We're using logs that have a base of 10. So log base 10 of 1,000, we often write it as just log 1,000. We understand that the base is 10. Much the same way as we understand that if I write down the square root of 25, the index here is 2. So if I write down log 1,000, I understand that the base has to be 10. We can use our graphing calculator and the log key on it to evaluate log 1,000. So if we were to have to do that with exponential form, if I was to calculate this out the manual way, I have log base 10 of 1,000 equals v. So I have 10 to the power of v equals 1,000. How would I write 1,000 as a power of 10? 10 to the power of 3. So then I get that log base 1,000 would be equal to 3. And then if I use my calculator, I have log 1,000, and there's my 3. So your calculator is a bit different, Jessica, because with yours you can actually put in the base. So that will be a feature that we will have to turn off for your diploma, because that's part of, you're not allowed to have that part. Okay? So now if I look at class example number 6, it says estimate the value to the nearest whole number without using technology and explain the reasoning, and then approximate using technology. So if I have log base 10 of 89, in exponential form, that would be 10 to the power of something would equal 89. So what would I choose for my value of v to get close to 89?
2
Okay.
would be like close, would be 100.
Okay, so would I choose a number more than 2 or less than 2? Less than 2. And we're having to estimate with using technology. So I know that it has to be more than 1, because 10 to the power of 1 would be 10. I know it has to be less than 2. So I might start off with, maybe I start off with 1.5. 10 to the power of 1.5. And what do I get when I put in 10 to the power of 1.5?
31.6 to 10.6.
Okay, so that's obviously not big enough. So then I want to go higher. So maybe I jump up to 10 to the power of 1.7. So I'm getting closer. So again, if I wanted to, I could jump up by 2 again, 2 tenths. 1.9, 10 to the power of 1.9.
79.4.
So that's pretty close to 89. So to 1/10, 1.9 would probably be a good approximation. Now if I actually calculate it by pressing log 89, what do I get?
1.9.
So 1.9.
4, 9,
So to the nearest hundredth would be
9,
9.5. And we were close in our approximation. We still did use technology to help us get that approximation. So really them saying to the nearest, or sorry, if I was going to the nearest whole number, 2 would be my estimate. If I had to go to the nearest tenth, then I'm going to have to grab the calculator. So if I look at B, this log 2,000 would be log base 10 of 2,000, which then means it's 10 to what power equals 2,000? So what whole number would get me close to 2,000? 10 to the power of what?
3.
3. So to the nearest whole number, my answer would be 3. If I wanted to get closer than that, if I wanted to go to the nearest tenth, then I would have to use the guess and check. Or what might be easier is if I could just type in log 2,000, in which, what would I get to the nearest tenth? situation. We have log base 5 of 25 and we want to convert this into exponential form. In exponential form, I let this be equal to v. 5 to the power of v equals 25. I write 25 as a common base of 5, and I get that v equals 2. So then I can state that log base 5 of 25 is equal to 2. If you take your calculator right now and you go log 25 divided by log 2, and then go natural log 25 divided by natural log 5, what do you notice? What do they equal?
Both equal to.
They're both equal to. Okay? I want you to do the same thing on B. Take log base 3 of 243, solve it by putting it into exponential form, and then use the calculator for the log form. Okay. Log base 3 of 243, when I convert that to an exponent, what do I get?
So you messed up.
3 to the power 5.
3 to the power 5, so then b equals 5. And what happens when I go log 243 divided by log 3 and natural log, natural log 243 divided by natural log 3? You get 5 as well. So on the first page of the lesson, we learned that log base 2 of 8 is equal to 3. So I could take log base 2 of 8 and I could evaluate this using a calculator by using what I've seen above. So from above, what would go on the top and what would go on the bottom? Log what divided by log what?
Log 8 divided by log 2.
And if I go log 8 divided by 2, what do I get? Are you guessing or are you telling me?
Yeah,
It's
I
2. You did. Did you close the brackets around 8?
No,
I
I
put in
did
a
log.
3.
So if I had log base 2 of 64, how could I use the calculator to evaluate this?
Log 64 divided by log 2.
And what would that equal?
6.
Okay. So this gives us this change of base identity. This is actually on our formula sheet. It doesn't say change of base identity, but this log base b of c can be written as log c divided by log b with another common base. What that means is I could take log base 4 of 1024, which would be log 1024 divided by log 4, which would equal what? Five. And if I did this, log base 2 of 1024 divided by log base 2 of 4, which on my calculator would mean going log 1024, open bracket, divided by log 2, close the bracket, and then go divided by log 4 divided by log 2, I will still get the answer of 5. So this change of base identity will allow us to do the next, I think, 7 or 8 questions. So if I look at class example number 8, log base 5 of 221. If I was to evaluate this, what would I put into my calculator?
Log 221 divided by log 10.
And to the nearest hundredth, what would I get?
3.35.
So then if I look at the second one, what would I put into my calculator?
Log 1 over 1,000 divided by log 2.
And what would that equal?
Negative 9.97.
Okay, so I'll give you a moment to do the last one. So with the last one, it's 3 times, and then the change of base would be log 512 divided by log 7. And what do I get for my answer?
9.62.
9.62. So class example number 9 says to convert the following logarithms to the base indicated. So if I had log base 6 of 216 and I wanted to write it as a base of 3, the way that I would change that is I would write log base 3 of 216 divided by log base 3 of 6. I'm not evaluating it, I'm simply changing the base. So then what would I have for B? Take a moment to look at it and write down what the change of, what it would be if I wanted to change the base to 5. So what would I get? Log base
5,
of
300,
divided by log
base 5 times 10.
of 10. Because this base here was a 10. Okay? So question number 10 says find the exact value of the following. So I'm going to give you about 3 or 4 minutes and I want you to do these 4 questions. Okay. I'm sorry, that's too funny. So negative log 7 over 343, if I was to put that into the calculator, it becomes negative log 1 divided by 343 divided by log 7, which ends up equaling positive 3. With B, I would probably do the log separately. So log to the power, or log 216 divided by log 6, which is 3, and I get 216. For C, becomes, sorry Evan, I'm erasing my numbers. They're my way. Log square root of 1 divided by 1024 over log 2, which equals negative 5. And then this last one is log 49 to the power of negative 5 divided by log 7, which equals negative 10. Just go into the same room that you were in before and see Mrs. Campbell. She'll help you. I'll be right there. So your questions are 6A, 7, 9,